Welcome back. Let's talk about inheritance. A core aspect of object-oriented programming is inheritance, which means passing knowledge down. Remember, at the start of this journey, we decided that we want to create this game, this fairy tale game that had all these characters. And we started with elves, just a couple of elves. But as you can see, our goal is to have many things. We want to have maybe a dragon, a knight, a king and queen, maybe some magicians. Yes, even Dracula. So using this object-oriented programming principle of inheritance, how can we accomplish this with the work that we've already done? Let's have a look. We have our elf class here. Yes, we've seen it before, and it shouldn't be anything new. But let's say that I wanted to have a new player, and this player is actually an ogre called Shrek. How would I go about creating this ogre? The one thing I could do is to copy and paste this code and create an ogre class. I mean, that's copy and pasting dry code that eventually we want to avoid, because as we keep copying and pasting, we just have repeated code, which gets messy. So one option that we might have here is, well, let's just copy the elf and maybe we can extend it. So for example, if I want to copy Fiona, let's say Fiona over here, if I click run, I have this elf class or elf instance with all these properties. Now, in order to copy what we already have, we can just do something like this. We can say const ogre, and ogre is going to equal, well, let's clone Fiona. And as I've shown you before, we can do ... spread operator, and then just do Fiona. If I do this, let's remove the spaces, and I look at what ogre is now, and I click run, look at that. I've copied Fiona into the ogre variable. And the interesting thing here is if I do ogre dot underscore underscore proto underscore underscore, what do I get? I get an empty object. What if I do Fiona? I have elf. So I've cloned the object, but ogre no longer has elf as the class, the base class. So that if I do here console.log Fiona equals ogre clone, and I click run. Oh, and I don't need the clone here. It should just be ogre. I get false. These objects are not referencing the same place in memory. They're completely different things. But I've also lost this chain, this prototypal inheritance chain. I can't even do ogre.attack. Nope, I don't have attack. So that's a problem. How can we extend this work that we've currently had? And this is where inheritance comes in. And it used to be really difficult to do with JavaScript before we had this class syntax. It involved a lot of ugly prototype code that, luckily for us, is now a lot cleaner. So let's have a look. To start off, to make naming a lot better, I'm going to change the class here to character, because all characters in this game are going to have name and a weapon, and they can attack. That's great. And now from this character, I'm going to create a class elf that extends, which is a keyword, this character class. This is something called subclassing in object-oriented programming. That is, we have a base class or a superclass and a subclass. That is, we want to inherit from the character class all these properties and methods and create something new out of it, extend it with elf. Let's have a look. If I just do this and I click run, all right, I get undefined. Let's see what Fiona is right now. If I do Fiona and click run, all right, look at that. Everything is still working. I have elf, name Fiona, weapons ninja. All right, great. But you know what? Let's make this a little bit more interesting. Let's say that the elf characters in this game, they also have an extra property that they can have. Maybe it's a type property as to what type of elf they are. So let's build that out. How would we go about doing that? Well, in here, let's add the type property. If I do a constructor in here, and I do this dot name or this dot type equals type, and let's say that we receive a type parameter in here. How is this going to work? We have to instantiate the elf class, and we give it the name and the weapon, but we also want to have the type. So maybe we'll do this. We'll say name and weapon, and the third parameter will be type. So I'll say that type of this elf, I'm going to change the name from Fiona to Dobie. The name is going to be Dobie, and the attack is going to be, well, or the weapon is just going to be a cloth, and the type of elf, it's going to be a house elf. All right, if I do this, let's see what happens. I'm going to click run. Reference error. Must call super constructor and derived class before accessing this or returning from derived constructor. Does that make sense? Not really, right? I mean, that's a pretty confusing error message. What is it saying? In order for us to have our constructor and be able to use this and know what this is referring to, which is elf and not the character, because remember we have both name and weapon, we have this special keyword called super for superclass. And this superclass we call like this. And by doing inside of the constructor the super call, it says, hey, call the superclass. What's the superclass of elf? Well, that's character. It extends character. So it goes up and calls the constructor so that we create this dot name and this dot weapon. So in here, we have to pass it name and weapon. Now I know this is a little bit confusing, this whole super thing. It's just a standard, especially with classic class-based languages, where super is referring to the superclass. Let's have a look here. If I click run, look at that. I got elf, that is Dobie, weapon is a cloth, and has a type, well, it's a house elf. And if I do Dobie.attack, attack with cloth. Not very effective, but it's working. Now, let's go over this one more time. When we do class elf extends character, it means, hey, extend and set the prototype, that is the __ proto, to point to character. So elf now has a prototype chain up to character. It's saying, hey, anytime you run an instance of elf, like Dobie, and it uses a property or a method that I don't have, well, then look up to character and tell me if character has it. The constructor is our own constructor just for the elf class. This is something that only gets run with an elf, not with a character. And in here, we can leave it as is. But if we want to set any sort of property, that is, use the this keyword, we have to call super and say, hey, call the constructor of our superclass, And then after that, I'll know what to do with this keyword. Let me show you. If I do console.log here and do this, and I run, that gives an error. Because in order for us to use the this keyword inside of the constructor, when we extend something, we have to call super first. So that if I move the console.log to under the super call and I run, look at that. I have elf that has name and weapon attached to it. So this, because we call the super, runs the constructor. We now have a instance of character with these properties, and then we can use this dot type to add type to it, so that by the very end of our construction process of elf, we have all our properties set. Very, very cool. And remember, the this keyword simply says, who am I? Who's calling me? In this case, we use the new keyword, so this is going to be set to elf. All right, but we started this video with us wanting to create an ogre. So let's do that. Let's continue on. Let's create another class that's going to be an ogre class that extends the character. We do the same thing now. Let's say that our ogre has a constructor, and we want to pass in a few things, such as name, weapon, and you know what? Ogres have different colors. So let's do that. Let's add a color property. And what do we do here? Well, we're going to call the super class, which is character, with name and weapon. So that now we can use this keyword to attach new properties to the ogre class. I'm going to add a color that equals whatever color we give it. And you know what? Ogres, they have special powers. Let's say that ogres can also make forts. So we have a make fort because, they're very powerful, obviously. And they'll just return, let's say, strongest fort in the world made. Nice and easy, just like that. Let's see if this works. If I create, let's say, Shrek, and Shrek is a new ogre with a name of Shrek. Weapon is going to be a club. And then finally the color, obviously, green. If I do Shrek dot attack, or let's just do Shrek here to see what we get. Look at that. I have a new ogre that was just created for me. How awesome is that? And if I do make fort here and run this, look at that. I'm able to use make fort function or method on Shrek. But if I go and do make fort to Dobby, nope, Dobby can make fort. He's very, very weak. There's not much that he can do. He's just a house elf. So let's go back to attack here. How cool was that? We were able to keep our code nice and organized and extend our base class character to create all these different characters in our game. Elf, we have ogre, we can keep creating different things like knight, magicians, princesses, kings, queens. And we can reuse code that we've written before, but also extend these classes to have their own individual unique things, like properties like type, or even methods like make fort. This is a simple example, but you can imagine the power of this as we get more and more properties and methods and bigger objects. Now let's take a break here and revisit this code in the next video.